Hello everybody. I'm standing here in a little tiny church in North Germany in the little village of Damnatz. The church is 400 years old and it's standing in an area where the father of Bernhard Riemann was a priest. And the next village is Quickborn, where Bernhard Riemann also was visiting his father very often when he went to school in Lüneburg. And I'm here in this church especially because I have here my paintings hanging on the walls for an exhibition, and the paintings are all dealing with a mathematical subject, which is the distribution of the prime numbers. I have discovered a symmetry pattern within the distribution of the prime numbers. And before I go into details about this distribution pattern, I show you a little bit around in this church to give you an overview of what my paintings are like. Of course, I will later show these paintings in better photographic quality, but I would like to share with you the experience of seeing them here in this environment all together. See, there's even an organ. And it is a great pleasure to present my work in this frame. By the way, this painting I submitted in 2019 to the British Mad Art Congress in Linz. I will later precisely explain how these paintings are built up. In this case, the number string is in a circle, starting with 0 at the top and 180 at the bottom. Okay, let's get to the mathematical background of my paintings. On this page, you can see two pyramids of numbers. They all contain the same numbers, only that the upper one is colored to illustrate the symmetry. In this case, the symmetry of the prime numbers, which are standing right and left next to the middle column, which is consisting of the TPAs. These are the twin pair averages. They are the numbers between the twins. If you add up the twins, for example, 71 and 73, you get 144. And if you divide that by 2, you get the number in between, which is 72. The upper one is colored, as you can see, in different colors that are standing right and left symmetrically. Beyond the twins, there are a lot of more and more prime numbers existing also in symmetric positions. And I call these numbers beyond the twins, I call them siblings, brothers and sisters, as the twins are brothers and sisters as well. And all the prime numbers in one line I call a prime number family. So here we have the prime number families named after the TPAs in the middle from 2 to 348. That means we have on the left side all the numbers, prime numbers up to 347, and mirror-like, the last lines are of course going beyond 360. On this graphical presentation, we see what I call an isolated prime number family. In the center of this diagonal line, we have the 72, which is a TPA, and left and right of it, there is 71, 73, as I mentioned before. Now, if you look at the upper left part and compare it with the lower right one, you see that the distribution of the prime numbers in this interval is exactly the same. If you consider it a kind of a propeller and you turn it around by 180 degrees, it will be the same as before. I have a computer program that finds out all these prime numbers that are standing symmetrically, and very often, actually almost always, you find in this complex of numbers, you find another another twin pair. In this case, it is, for example, 137 and 139. And if you put that in the center of a new graphic, then you find a bigger prime number family, and so on and so on. This is one of my latest paintings. It is actually the most important that I want to comment and explain. It has as a construction actually the same as the graphic before, only that in this center of this painting there is the TPA 348. And the painting is 1 meter 74 by 1 meter 74. That means that 4 numbers I put into 1 centimeter. So from each number to the next, it's 2.5 millimeters. I said that the TPAs on this painting are from 2 to 348. You probably will be amazed about mentioning the number 2, because that 2 is between 1 and 3, and 1 is not anymore considered a prime number. But it was in the 19th century, and all my paintings or constructions and also graphics are including the 1, which I hope you as mathematicians will excuse me as being a painter. Being a painter, I want to mention something about the colors I'm using in this painting. There are 7 different colors, and if you count the colors, you find out that the 8th is the same as the first. It's a bit like in music. C, D, E, F, G, A, B, C. C is the 8th and is the same as the first. So in this painting we have kind of 3 octaves, because I included the 1 as a prime number and the 2 as a TPA, that it adds it up from 2 to 348, adds it up to 22 prime number families and TPAs, and that makes it a little bit also looking musically. I have heard some people say that. By the way, I'm also a musician, and I can see also the connection between visual arts, mathematics, and music. And you might have known and read the book, the Music of Primes by Marquis du Sautoy, which I had a very great pleasure to read. It's about the Riemann conjecture. Since I was in Linz at the Bridges Math Art Conference, someone investigated my discovery of the symmetry of the prime numbers, and he wrote something that is probably also interesting you, and I will show this now. So what you see here was written by Professor Jörg Arndt from Nuremberg after he saw my number material, and it is what he calls a Riemann conjecture, and I'm trying to read it to you, and you also can make a print screen. He wrote, the following assumes the twin prime conjecture is true, conjecture by Walter Riemann. We use the abbreviation TPA for twin prime average, given in HTTPS OA's organization -A014574. For every odd prime P, there exists a TPA M, what's that, bigger than P, such that P multiplied by M minus P is prime. In other words, for every prime we can find some TPA M such that there is another prime P1 with M equals P plus P1 divided by 2. For every odd prime P, there is an infinite sequence of primes, P1, P2, etc., such that M equals P plus P1 divided by 2 is a TPA, which we choose to be minimal. M1 is P1 plus P2 divided by 2 is a TPA, and so on. For every odd prime P, there are one or more and possibly infinitely many TPAs such that for all those TPAs, M quotes K, one has MK equals P plus PK divided by 2, where PK is prime. This gives for each prime P an infinite tree with root P. So I hope you could follow this. And now I will show some more of my paintings just to entertain you a little bit with visual art dealing with mathematics. Here you see 6 paintings, and the left one, for example, has the prime numbers in a circle, the number string as well, of course. And there are only twins, right and left, standing symmetrically to the x from the top to the bottom. This x starts at 0 and ends at 1050, having the twins 1049 and 1051 next to the TPA. This one has the number string going from the top to the bottom, starting with small families, and they are getting bigger and bigger and bigger. And the blue one is framing the whole thing, so kind of, and has the center, of course, in the middle. And yeah, that's how this is built up. Um, Also here, the 348 is in the center. In this one here, we have also the number string going from the top to the bottom. It's 144 centimeters by 144. So that means that 72 is in the center. And that's the blue family. And then comes the violet one that has the center 60. Then the center 42. Then the center 30 and 18 and 12 and 6. By the way, the TPAs are always 6 or multiples of 6. The exception is only the 4 at the beginning between 3 and 5. Here, this painting, that's the one with only twins at the right and the left. Um, if you are interested to get into details about all my work, you have a look at my website, which is German, has a German long title, Primzahlen Verteilungsmuster. That means prime number distribution pattern in German, and it is also written in the title of this little video. This painting has 360 numbers in the circle, and at the bottom is 180 between 179 and 181. And at all these corners, there are, at the same colored colors, of course, are numbers that add up to 360. So I say goodbye. Have a nice Congress. Bye-bye, Walter Reimann.